Bonjour à tous et bienvenue pour ce nouveau webinaire Easy qui aujourd'hui est fait conjointement avec notre partenaire SMH et qui va traiter de la programmation et une-circuit de programmation dans un contexte automotive. Et comme je viens de l'énoncer, je vais être accompagné aujourd'hui par Yvan Leberotti, qui est ingénieur software et firmware au sein de SMH et qui fera la partie principale de cette présentation. Et personnellement, je suis Frédéric Maraval, je suis ingénieur produit au sein de Easy. Avant de commencer, quelques informations sur le déroulé de cette session webinaire. Donc la session sera enregistrée et sera mise à disposition sur demande à la fin du webinaire. Durant toute la partie de la présentation, les micros des participants seront coupés, mais vous pourrez toujours interagir de manière temps réel avec nous à travers le canal questions que vous pouvez retrouver sur le panneau de contrôle de votre session GoToWebinar. À la fin de cette session, il y aura une partie de questions-réponses, mais n'hésitez pas durant toute la présentation de poser vos questions en avance dans le chat. Et d'un point de vue pratique, veillez éventuellement à noter le numéro de la slide pour lequel vous avez la question. Ça peut nous aider à vous répondre plus facilement ou à voir ou à interpréter de manière plus précise vos questions. Et à la fin de ce webinaire, vous sera envoyé un sondage qui ne sont que quelques sessions qui prennent très vite à répondre, et je vous remercie par avance de bien vouloir répondre à ce petit sondage. Ça nous permet d'affiner, de toujours améliorer nos événements de type webinaire. Alors pourquoi aujourd'hui on parle de la programmation dans un contexte automotive et en relation avec SMH? Tout simplement, ces dernières années, depuis quelque temps, la complexité et la performance des cartes n'a cessé de s'élever et de croître, et ça a amené en fait de nouveaux challenges, de nouveaux défis à relever, notamment comment combiner les aspects de cadence et de robustesse de programmation vis-à-vis des délais et éventuellement des nombres de cartes à produire. Également, dans cette évolution, comment intégrer les équipements dans les lignes de production et également garder une flexibilité pour pouvoir évoluer et faire évoluer le plus facilement possible sa ligne de production. Et également, ces dernières années, des nouveaux risques sont apparus, et notamment tout ce qui concerne autour de la cybersécurité. Comment, à travers la partie et les phases de programmation, peut-on amener un niveau de sécurité ou se prémunir de certains risques lors de ces phases de programmation? Et pour répondre à toutes ces questions, quels sont les apports et des solutions SMH? Je vais laisser la main à Yvan pour faire la présentation et vous amener les réponses à toutes ces questions. Yvan, I give you the control and you can start your presentation.
Okay, hello everybody. You should see my presentation at the moment. Okay, through these slides I will give you a general overview about our products, SMH FlashRunner 2.0 line products, and then we will see some production line integration examples, and maybe we will go through also the graphical user interface, how to set up projects, and then we will speak about cybersecurity concerns and how SMH is interfacing with these issues arising from cybersecurity. So first of all, SMH is market leader in system programming solution. What SMH provides to their customer, what we provide to our customer is hardware and software to be ready to manufacture your electronic boards through our systems. We have a relationship worldwide with the most important business players in this kind of sectors, such as EasyIt, for example. It's one of our partners. And we are always investing in improving our solution from a both hardware and software point of view. Just a few words about our evolution. We started by being third programming party developer for debugging tools. I think something went down here. We were third-party developer developing system for ST microelectronics, and then from after some years we started focusing only on in-system programming. That is basically programming microcontrollers and components, microprocessors, and so on inside the customer boards. At the end of the day, after some years, we started developing a complete programming system to provide to our customer the best solutions to manufacture their boards in their industrial environments and production lines. This is one of our products called FlashRunner 2.0. As you can see from here, you can have USB UART interface to connect it to a PC, Ethernet LAN connection to a PC as well. Then we have a control interface on the left side, which is able to receive some inputs on the lines and execute projects that are stored inside the FlashRunner. And on the top side of the product, you can see the in-system programming connector, which is actually the connector that handles the connection to the targets to be programmed. This is another FlashRunner 2.0 line product called FlashRunner HS. The concept of the two programmers are quite different, the programming concept, but they share both the same hardware inside and the same software, and also the device list supported is in common between the two platforms. Again, you can see the USB and Ethernet LAN connection to a PC if you want to use it. So our products are reliable and robust. They are designed to work 24/7 in industrial environment and production lines. We have hardware and software functions that are steadily updated during the years, and we provide also support free of charge on all the products we are selling to our customers. We also develop dedicated industrial integration solution for our customer that needs to integrate these platforms in their production lines. At the moment, we count a device list of 15,000 devices already supported, and we are keeping going on with these devices. Here, you can see the flexibility of our products. What I'm saying is that our products is a universal and parallel programmer. We are not related or bounded to any silicon producer. We are basically available to support every kind of microcontrollers coming out from every silicon producer. And we can support all the protocols, the communication interface that the device provides because of our hardware inside. The platforms can be bought in different configurations based on your needs. For example, you can see the FlashRunner NXG on the top of the slide. It can be bought in 1, 2, 3, 4 channels that are independent, so they provide parallel programming for different as well microcontrollers. We have the FlashRunner 2.0 8 channels and 16 channels that can be declined in this configuration you see on the slide. And then on the top right of the slide you can see the HS, which is composed by a control unit from where some 8 links are coming out. They are USB Type-C cables that can reach up to 6 meters. And actually, the object that is performing the flashing of our ISP targets are the active modules that you can see here at the end of the USB Type-C cable. We will talk about their functionality later in the slides. Anyway, from here you can see that for project that needs 1-2 channel, you can have a solution. For project that needs 8 channels, you can have another solution, 16 channel, up to 32 channels, which is the FlashRunner HS. Our aim is, of course, to provide to our customer the most production efficiency they can come out with in their production line. And for this, we aim to have fast programming speed, be through parallel in programming our devices, and we provide a full programming system for these industrial environments, which in the future are getting more and more complex and demanding from software point of view and hardware point of view. For example, cybersecurity, complex board that needs multiple channels, parallelism in many different ways. These are the active modules I was talking about, the FlashRunner HS. As you can see, we developed single solution for different architecture, which are specialized to flash the architecture they are supporting. For example, on the top left of the slide, you can see the GP4, which is a general purpose active module. This allows you to program, let's say, mass market microcontrollers that are using communication protocols such as JTAG, SWD, UART, I2C, and the most common one. Then you can see the EMC active module. As the name is saying, this active module allows you to program the EMC architectures. And then we go on with the Octal SPI active module, NAND active module that are specialized to program the architecture they are taught for. We have also developed the CAN module, which allows you to perform also end-of-line testing on your boards at the end of the production. For example, once a firmware is installed inside the microcontroller and you want to perform some functional test on the firmware, we have the CAN module which can communicate with the device and send some CAN frame to check if everything is working fine. Basically a functional test. In this way you can, for your needs, you can also compact the two phases of programming and functional test, saving time in your production. We have developed also some plus active modules, so-called. For example, the UFS active module, which is able to program the UFS storage, which are coming out these years in the market. USB active module to program memories connected to microprocessor that are interfaced to FlashRunner with the USB interface. And also we have developed the Automotive Ethernet active module for the same reasons. This is a summary of what I'm saying. We have different active modules that are specialized to function for their specific architectures, and they have their specific characteristics that maybe we can analyze later when I'm going to talk about the integration of these active module inside your machinery. So from what you can see in these slides here, okay, we have two different ways of using FlashRunner 2.0 NXG and FlashRunner HS, and also different ways to integrate it in production lines. For FlashRunner HS, which is using this particular concept of having a control unit connected to the active module through a Type-C USB cable, it can be hard to integrate it in a production line. I mean, not hard, but let's say more complex than the other solutions. So we developed a collaboration with some of the most important players from this side in the world, VPC, Virginal Panel Connectors, and ODU. And we developed in collaboration with them some high-performance interconnection that can be suitable to integrate our products, in particular FlashRunner HSS, in your industrial environments and production lines. Here you can have some images of what we used from their company, okay, this model here, and what we developed using their parts. So we will have the following slide will show you some example of how to integrate our FlashRunner HSS in your production line, some ideas. So basically here you can have the control unit of the HSS in the machine, and you can have some USB Type-C cable connected to this object you can see in this slide. And on the fixture side, you can have another object that is the counterpart of the first object I showed, and some USB Type-C cable in the fixture that are reaching the active module. In this way, you can see that the active module is placed really close to the target. And from the ISP connector, which you can see at the end on the counterpart of the USB Type-C cable, you should have a really short wiring to reach the ISP target. Having a short wiring allows you to increase the communication frequency of the protocol and lower down, in some case extremely lower down, the programming times of your microcontrollers you want to program, or EMC, big size memories, and so on. This is an example of integrated with Type-C USB cable. Here is an example of direct plug, okay, but the concept is the same. Now we will have the same concept based on ODU solution. We developed this solution here, and you can see it integrated, an idea of how to integrate it in your production lines. And this is one of the concepts that I would like to clarify for you, which means you can have an hybrid integration, because some active module, like for example GP4, are specialized to program microcontrollers, as I was saying before, that are common in the market and use the most common protocols like JTAG, UART, and so on. This kind of protocol does not really benefit from having the active module really close to the target, because the point is that even if you are raising up the frequency of the communication protocol, at the end of the day, the bottleneck would be the microcontroller itself. So you can transfer data to the microcontroller to be programmed inside the memory, but then you would have to wait for it to program itself, okay? Some other active module instead are taught to program big size memories, such as EMC active module, for example, Octal SPI active module, and so on. So this active module instead really benefits from increasing the communication frequency, because actually doubling the communication frequency of the protocol means halving the programming time of your target. So this is why we are showing this slide. In some way you can have an hybrid solution by integrating some active module which requires low frequency anyway, because they do not benefit of having high frequency machinery side, and you can have active module which instead really benefits from having an increasing of the frequency inside the fixture. Okay. This allows you to keep the part of the machine available for other production, other projects, if you want to change them, and capitalize the cost, okay, that you would have for this particular project into other projects. The fixture side instead follow the operative cost for your single project, your single production line. Okay. This is a slide of a pylon block, which is maybe which could be a solution that we suggest to integrate the, for example, a GP4 that needs to reach the fixture side. You can have it in this way. Also, we have some forecast in the future. We could have a VPC machinery that is integrated in a FlashRunner 2.0 channel with an integrated relay barrier. This is a future project we would like to have with our partner VPC. This is a solution called FlashRunner HS Compact, which is basically combining the two solution, FlashRunner 2.0 and HS, and benefit from both parts. So basically, as you can see, from a FlashRunner 2.0 point of view, okay, once the ISP connector is configured to program microcontrollers, you cannot mix an eMMC memory or an AND memory together. With the HS concept instead, you have 8 links that can mix and match these different architectures. For example, microcontroller together with eMMC together with a CAN module together with other architectures. The FlashRunner HS is thought to mix these two things. Basically, you can have all the functionality of a FlashRunner 2.0, but with this technology, you can also mix things that you couldn't do with NXG or FlashRunner 2.0. You can also mix the different architecture of our portfolio: NAND, serial, octal SPI memories, microcontrollers, eMMC, all together. Now we can talk about some software features that the FlashRunner is providing to our customer in order to provide a full programming system for the industrial environment. I will introduce some concept here. For example, the workbench is our graphical user interface. We have a graphical user interface that handles all the platform I presented till now, HS, NXG, FlashRunner 2.0. And this graphical user interface is used by our customer to start using the FlashRunner 2.0. It is not a production tool, a production line tool, but this is useful to create project really easy, to create all the flashing resources that the FlashRunner will use during your production line. So basically, the first step to take is to use the graphical user interface to create everything that you need in order to use the FlashRunner in a production line in the best way. We have the drivers, which are basically the flashing algorithms that we developed to support the flashing of the microcontrollers. These are some library installed inside the FlashRunner when the customer requires it, and they are basically the object that is handling the flashing of your ISP target. We have also a light Linux distribution installed inside the FlashRunner, such as used as an operating system. Okay, and then we have the project, as I was saying. The project are basically a text file containing a list of instructions that the FlashRunner will parse and then will execute for programming your target device. The device SMH file is basically our database. Our database contains all the information about the device we support on our device list, and this file is basically the export of this database in a format file which is encrypted to not make data clear to whoever wants them to be available. And this is used by our graphical user interface to allow the customer to create projects in a very easy way. We will see now how all these parts are interacting together. So basically, the graphical user interface is available free on our website. You can download it. Once you would have it installed in your PC, you would like to have all our database updated to the last version. So there's a button. Maybe we can then see the graphical user interface. There's a button that allows you to download this file and have all the device list updated to the last version of it. After that, you can use the graphical user interface, the workbench as we call it, to build your project and your FRB files. The project and the FRB files are interacting together to give instruction to the FlashRunner on the operation to be performed on the microcontroller you have connected to the platform. The project is, as I said before, the list of the instruction. The FRB file is the firmware file that you want to program inside the memory you chose to program. FRB is an acronym for FlashRunner binary. Basically, the most common source file in the market are Intel X file, Motorola SREC files, this kind of format. And once you upload these kind of files into our graphical user interface, the graphical user interface will proceed by generating from that input files an output file which is called FRB, which is basically a file that is lowering the load of the data that the FlashRunner should handle in order to program your target device. Intel X file, Motorola SREC file has a lot of overhead, like they have the CRC for protection, the addresses of the memory where you want to program the data, they have the sites and so on. The FRB file is basically getting the raw data from that file, adding some intelligent things that FlashRunner will understand, and then program the data inside the part of the memory described in the Motorola SREC file or Intel X file. If you are given a raw binary file, you would still have to convert it into an FRB file, giving also the address where you want to program this raw binary data, because the raw binary data does not have any overhead. It's raw data, and you need to give the FlashRunner. But this is handled automatically, and we will see it later in the slides. From here, we can start seeing some slides taken from our graphical user interface. We have here the pin map tool for FlashRunner 2.0 platform. From this window, you can select the other architecture like NXG HS. And sorry, there's a bit of confusion here. Okay, so we have this tool of the graphical user interface, which is basically showing you the connection that you need to perform from the ISP connector that I showed to you before to the target device. Here I take just a generic device to show all of the first channel, for example, of the FlashRunner. You have to imagine this as a 8 channel. This is actually it is a 16 channel version. Okay, sorry, it's a 8 channel version. This part is the first channel, then this is the second, the third one, and so on. And these are all the DIOs that are in the first channel. We have 2 ground pins, the VPROC 0 pin, and all the other DIOs. Basically, once a device will be selected, here you will see the protocol of the device that we support, and here you will see the list of the connection you have to perform from the ISP connector to the target device. We will see it later. Then you have also the memory map tool, which shows you what are the memories that we are supporting of that particular microcontroller. For example, here I took, for example, an Infineon tri-core device, and this is the list of all the memories that we are supporting through FlashRunner. arrays and program memories, flash, data flash, UCB, and so on. This is a file manager tool. This is an important tool that also allows you to understand how FlashRunner is working. Basically, the LAN and the USB interface that you can use to connect the FlashRunner to a PC are used at the beginning to transfer file inside the FlashRunner. But once the file are inside and they are stored in an SD card, and this is the graphical representation of your SD card. So as you can see, it is divided into 4 tabs: project, drivers, licenses, FRBs, and then we have also a log feature that allows you to log all the operation that you are performing during your production. Once everything is loaded inside the FlashRunner to the graphical user interface, there's no need to use the FlashRunner connected to the PC. You have all the flashing resources stored inside the SD card, and you just would need to run the project that is giving the instruction to the FlashRunner on how to program your target device. Of course, the algorithm is a must, because then if you give a project and there's no algorithm that is running the project, then the instruction will just fail, together also with the firmware file that is actually the object that needs to be programmed inside the target memory. This is the FlashRunner binary manager tool, the FRB manager tool. As I said before, the FRB is a conversion of your source file, Intel X, Motorola, Slack, Raw binary, and many others format we support, into our FRB format. So you can use this. It is really intuitive and simple. Maybe we can have an example to see it later. Here, from this window, you can upload your, through the Add button, you can upload your firmwares, and you can select the format. We have other formats, but basically the format that are silicon proprietary, such as Infineon has its own format sometime, Renesas has its own format sometime. They are listed only when you are selecting a device belonging to that particular silicon producer. We have RPI for Renesas, we have AHEX for Infineon, and so on. We have many of them. And these allow you to create your FRB file in an automatic way. And then you would also have a conversion report that is telling you what has been done to convert your input file into our FRB output file. So this is for testing phase, I would say. So the graphical user interface is used for testing your solution on a bench, on your laboratory, and so on. For moving into production, when you have to automatize the flashing process, you have to handle FlashRunner not through a graphical user interface, we have developed DLS and command line tools. So what is important to say about our DLS and command line tools? They can be easily integrated in environments such as LabVIEW or TestEnd. Most of our customers in their production lines are using this kind of application. Most of our customers are using let's say, this software to automatize their industrial environments and production line using our FlashRunner. We have developed them in C, C++ application and C# application. What is important to say, we have just, they are very easy because we have just three, let's say 3-4 DLLs that allows you to transfer file to the FlashRunner, allows you to run projects that are stored inside the FlashRunner, but since we said that projects are a composition of instruction, the DLS allows you also to execute single instruction of the project. So you can run a project that is a list of instructions, but you can also run a single instruction to make something. One of the most common things is once you program the device, through a DLL integrated in a test-end application, you maybe handle also your power supply through the LabVIEW application. You power cycle the board, and then you perform some functional tests with our DLL, launching single commands and not a whole project, because you don't really need whole project. The important thing is to have the right driver inside. Command line tools, we have the FR transfer, which allows you to get and send file from FlashRunner installers or from your PC to the FlashRunner. We have the FlashRunner command to execute commands on the FlashRunner. And then we have also the FRB converter, which allows you to create the famous now FRB into from your input file. How do they cooperate? Basically, instead of having the graphical user interface workbench in the middle, you have DLLs. You know that the project and the FRB, it is not more needed to create them through the graphical user interface, because you already transferred them into the FlashRunner. So what you have to do is to integrate DLLs in your test-end application, LabVIEW application, and through our operating system, launching some commands that are executing the project, which is stored inside the FlashRunner. The operating system basically is keeping communicating with the flashing algorithm to execute the instruction in the project launched by our DLLs. For the FlashRunner 2.0 and NXG, we also have some integration tools, hardware integration tools, such as the relay barrier, which allows you to provide galvanic isolation from the FlashRunner. Basically, it disconnects completely the ISP lines from the target, and you can perform functional test, ICT, without having any interferences from the FlashRunner. We have the demultiplexer, which allows you to multiply the FlashRunner lines. So you must consider that this is not anymore parallel. It is a serial programming, but you are actually doubling the lines. So you can have up to 32. If you are using, for example, a FlashRunner 16 channels connected, you can have in the output 32 channels. But of course, keep in mind that there will be one row of 16 targets in series with one row of other 16 targets. Then we are also providing some this tool, the cable interface, to improve the signal integrity of your connection. Using this cable interface together with the header connector allows you to bring as many as the data lines together with the ground lines. Of course, you must be sure that, let me go back to the FlashRunner slide. Okay, here on the ISP connector, you will connect this cable interface. Then you will have SMH flat cable that are bringing ground lines paired to the data lines. But these are also going to one header, and from the header you must guarantee that your wiring to the target is as short as possible to not lose all the quality of the flat cable, because we can guarantee from the ISP connector to the end of the flat cable ground lines twisted pair that are guaranteeing signal quality. But then if you have 2 meters of wiring, then you are losing all the job that the flat cable is doing. Okay. And then we have some software advanced features that we are providing to our customer to complete the production environment they would need. We have some example here. We can perform serial numbering through the dynamic memory feature. Basically, every channel of the FlashRunner has a dynamic memory in which you can set dynamic data. and during the programming, this dynamic data will be installed inside your target device. The channels are independent, so also the dynamic data can be different from channel to channel. We have firmware encryption features that allows you to protect your firmware file, Intel X, Motorola SREC. The conversion into the FRD will be changed into FRS, which is FlashRunner secure, and that is the encrypted version of the FRD file. We have 4 different levels of encryption, from the most advanced one that allows you the best security you can have. Of course, the complexity of using that process is high, to the lowest one that guarantee you some kind of security and that is easier to be used on your production. So you can choose which level based on how much secure you want the application to be and how much complex you want to have. You want to have. And then we have also the real-time log feature, as I was saying. It allows you to keep track of all the operation you are doing during the production lines manufacturing, and the conditional arrays scripting, which is basically having project. The project are the object I was talking to you before, the project. You can have a script conditional project that allows you to perform or not some operation if you need them or not. One of the most typical example is that if you are sure that your production line is manufacturing virgin board and this particular microcontroller has 6 seconds of memory erasing compared to all the rest of the cycle, you can decide to not perform the, sorry, I went too fast, to not perform these arrays and save 6 seconds in your production line. Of course, if the functional testing is failing for some reason and you have to reprogram this microcontroller, in the second run, the conditional arrays will delete the content from the memory, because the script is, the project you are creating is a conditional project. So it basically checks if the board is virgin or not, and it will skip the erase process. Again, if the product is programmed, the functional test is failing and you have to rework it, the same script will check if it's virgin. That will be a failure, and then it will erase the memory and going on with the production. But at least on the first row of manufacturing, you will save all the erase time. This is the concept behind the conditional projects. Now we have some minutes to talk about the cybersecurity, which is really demanding in the automotive market. From a target point of view, which means the ISP target that you want to program, we provide functionality of OTP fuses programming, locking of the debug port temporarily or permanently based on your firmware, on your requirements, on your needs. Of course, we also, together with the lock, we also develop unlock features to rework your device unless this lock is permanent. HSM, I would add also HSC handling. HSM, hardware security module in some microcontroller, for example, Infineon Tricors, or HSC, hardware secure engine for S32K3 from NXP devices. We handle them. What is important to keep in mind, not all the microcontrollers have these features, so when they have, we support them. When they do not have, we cannot invent anything. And then we have also, we also develop, upon request, protect memory regions. If some devices have a sector protection, we can develop this kind of algorithms. About instead the FlashRunner side, we have, as I was telling you before, the 4-level, let's say we have 4 ways to encrypt your firmware file. Okay. We have, as I was saying, 4 levels of encryption. You can choose between 1, 2, 3, or 4 based on the complexity and the security you want to give to your project. The dynamic data that I was talking to you about before, that allows you to serial numbering your boards, insert password, and insert some manufacturing data on the memory of the microcontroller, they can also be encrypted if you don't want them to be seen by anyone. Of course, DLS are also supporting these features. It is not just graphical user interface features. So in your production, you can enable through DLS these kind of features. We have all the time you're changing FRB file, project file that you want to store inside the FlashRunner. During the transfer, we are always checking the CRC32 stored inside the content of these files. We are checking it, comparing it to prevent alteration of the files and so on. And then we have also hardware side, the user management. We introduced it in the few latest OS operating system. This is guaranteeing you a 2-level access on the hardware of the FlashRunner, admin and guest. So the admin has full access to the FlashRunner features. Basically, he can transfer files, get files from the SD card, he can run project, upload FRB, upload project, and so on. Full access to the FlashRunner features. The admin can choose what to allow to the guest. So basically, the guest has some permission that are chosen by the admin. This is really important when maybe some companies have their FlashRunner in their laboratory, their R&D, and they want to give it to production. Basically, the admin of the FlashRunner can choose to select what operation the person in the production should do on that FlashRunner. And then we have also, through this way, we can control the flashing cycles that some production should do or not. But we can clarify this maybe in the Q&A session if it's not clear enough. Okay. I think we can have like, I don't know if you want to check something about the graphical user interface features, maybe some visual hints on how it works and how it is seen. It could be useful for you before going to the Q&A session. So I will now put down the slides and get up the graphical user interface to show you how it is. Sorry, maybe this, okay, here. Okay, so this is our graphical user interface. You have the memory map tool here, the pin map tool we show in the slide here, and so on. You have some shortcut to the device list of the programmer. Okay, you can create a new project from here, and I will show you that is very easy. So you give a name to the project, and from here you can go through the creation of the project. You can choose your device. You can see again the pin map and the connection. I2C protocol connection here, channel 1 of FlashRunner 2.0. You can change the interface here based on the product you have. The memory we are supporting, EPROM memory of this device here, 512 bytes, so on. The algorithm that you need to have inside the FlashRunner in order to program this device. Here you have the FRB management, which is basically the part of creating the FRB from your input file, you can choose between these options. And once you upload basically a binary file, for example, here it is showing red. Why it is red? Because it doesn't match the memory map of the device. Basically, it is too big for the memory map. So you can click on the block and some option will pop up. You can duplicate, remove, cut some data, edit the data. Basically, the address is okay, and here you can see that the size is too big. From here, you can edit it like this. Of course, I'm making examples. And now there's no red anymore. Okay, you cannot see maybe if I add another one. Okay, you see this is green because we just edited to fit the memory. This is red because it doesn't fit. Once you click on next, this output file will be generated from this raw binary file here. And a conversion report will be created inside your PC. Here you can see the protocol, the frequency of the protocol. Usually the one showed by the graphical user interface is the one that is suggested. Okay. Okay, and here there are some power up time for your boards. Usually the default one here are the ones suggested, but if you have any particular needs on your boards, you can choose to modify them. Here, as I was telling to you before, we have the enabling of the VPROC0 pin, which is the pin that is allowed to give supply to your boards. We have two pins to give supply to the boards, VPROC0 and VPROC1. The VPROC0 is mostly used to supply your microcontroller, the single microcontroller. It goes from 1.8 volts to 5.5. Okay. The VPROC1 pin is instead used to supply the whole board, not just the microcontroller. In fact, the maximum that reaches is 13.5 volts. Of course, you must be sure that the current consumption is in the limit described in the reference manual of the FlashRunner. The VPROC1 has a limit of 200 milliamperes. So if the board is consuming more than that, it is recommended to use an external power supply. But you can keep in mind that there is the possibility to supply the microcontroller or the whole board from also the FlashRunner. And then you have some additional parameters particular for the device I've chosen that are described in the wiki section on our website. And there are also, that could be here additional commands, more than additional parameters, also described in the wiki section of our website. And then you have the standard commands that will do mass erase, program verify operation on the memory. I uploaded a file that is fitting the EPROM memory, so you can program and verify with that file the EPROM memory. If I wouldn't upload anything, these two buttons would be disabled, as you can see from mass erase blank check. Then when you click on finish, you can drag and drop the device here on the channel that you want to use. Here you can create multiple microcontrollers, and based on where they are connected to the FlashRunner, you can drag and drop them on the different. Remember that this programmer is universal and parallel, so you can program different microcontrollers with also different protocol. Once you click on finish, you can see the text editor. This is the project. These are the instructions that FlashRunner will pass in order to perform operation on your target device. This is the cybersecurity tab, the flashing cycle limitation, the user management, admin and guest. Here you can give the permission, and from here you have the firmware encryption features of cybersecurity that allows you to protect the intellectual property of your source file.